Hey everyone, welcome to Unit 7.1 video lesson. Today we are talking about greatest common factor and how we can factor some of these expressions, okay, and what that means to us. So in order to factor a monomial, we want to determine the numbers of the coefficient, okay, that would multiply together and the number of each variable. So really we're looking for this big long string of individual terms multiplied together. Okay, so I'm going to show you how we get the coefficient, okay, to be factored. We're going to do it all out by hand, and then in the future we're going to start to do it in our head. Okay, so really what we're doing with our coefficient is we're making a factor tree. Okay, so we're going to be looking for a prime factorization here. So we know 20 is 1 times 20, and we do want to include the 1 because we're going to want that to be part of our final answer. And then you can go ahead and split this up in any way, okay, and you will get down to prime numbers. Okay, so you then circle all of your prime numbers at the bottom of your tree, and that is going to be part of your monomial factorization. Okay, so see, we're listing out all of the individual terms that multiply to give us 20, and then we're going to do the same thing with our variable. So x squared is x times x and y squared. Okay, so the most important thing to remember here is that we do include the 1. All right, 1 is always a factor of every single number. All right, so like I said, we're going to start to try and do this in our head. Okay, so we're always going to start with a 1, so without even thinking, we can put that down. All right, and to get a 12, two times 2 times 3. All right, so when you're first starting out, if you need that factor tree, if you really need it, okay, you can go ahead and make one off to the side. Eventually, we are going to let go of that, and we're just going to start to do that in our head. Okay, and then the variable is the easy part. So g to the 4th, h to the 3rd. Okay, but that is our monomial factorization there for 12g to the 4th, h to the 3rd. All right, so why don't you go ahead and pause your video and see if you can't factor 32x to the 4th yz squared on your own, and then come back in and check your answer. Okay, so like I said, we always include the 1, and 32 is 2 to the 5th power. So we have 2 times itself 5 times. Okay, x to the 4th y z squared. Okay, so I understand these types of problems can have very long answers, all right, but there is a purpose for this. This is building us, okay, to our final goal here for the day. Okay, we're getting there slowly but surely. All right, so now we know the greatest common factor is the largest integer and or variable combination that divides each term of a polynomial without a remainder. Okay, so it means that it goes in evenly. So we should at this point know how to find the GCF for a coefficient. When we are finding the GCF for a variable, we take the smallest number exponent for each variable. Okay, we can only take out the smallest number that's available. I'll show you what that means when we look into an example. All right, so if we're trying to find the GCF between 12a squared b squared c and 18ab cubed. So we're going to use regular GCF skills for 12 and 18. So what is the largest number that divides into each of those? Okay, should be 6. Now I'm going to look at the variables one at a time between each monomial. Okay, so between a squared and a, if you had to take the same number from each one, how many would you have? So I can only take one a because 18 only has 1 to give. I can't take 2 from it because it doesn't exist over there. So far, the only thing that they have in common is a factor of 6 and 1a, or a to the first. How many b's could you take? You could only take b squared, okay? Even though this has 3 to give, my first monomial only has 2. So we have to go with the smallest number present. All right, and could we take a c? We could not, because 18ab to the third does not have any to give. They don't have that in common. So that is my GCF. Those are the only factors that I could take out of each expression. Okay, so we're going to find the GCF again. All right, this time my terms just happen to have operations in between them, but we're going to do it exactly the same way. Okay, so between, I think if we do the coefficient first, between 20 and 28, okay, the greatest common factor is 4. Okay, so that's the biggest number that will divide into each of them. Okay, how many x terms would you be able to take from each one? So if you have an x to the 10th and an x to the 4th, you have to go with the smallest amount available. And that's x to the 4th. And finally, I can take y to the first, because the first term of 20x10y over here only has 1. All right, let's do our last example. If you want to pause and try this one on your own, okay, I encourage that. So between 12, 15, and 3, the GCF is 3. I can't take out an x because my third term does not have any. And I could take y to the first because that's all that they all have to give. Okay, so it's important to note the specific instructions here. The directions say find the GCF. So that's all that it's asking you to do and to state, is just find what the GCF is. Moving forward, okay, the directions are going to ask you to do different things, and you need to know what each one is asking for so that you state your final answer in the correct form. Okay, because now we're going to use the distributive property to factor polynomials. So before we were just stating the GCF, now we're going to use GCF to factor. Okay, and factor is going to make it look like a distribution problem. Okay, so determine the GCF of the polynomial is the very first thing that we need to do. And then we're going to use division, okay, to factor it out from each term. stating the GCF on the outside of the parentheses and then putting whatever is left inside makes it look like a distribution problem. And that's what a factoring answer should look like. A factoring answer should always look like a distribution problem. So let's take a look at some examples and see what all of this means. Okay, so the GCF for 5x and 10xy. Okay, my GCF would be 5x. So it says that we now divide this out from each term. So first write down my GCF, and I need a distribution problem, so I know I'm going to use parentheses. And this gets divided out from each term. So now I've kind of set up these little mini exponent problems. 5x over 5x, it's division, so that should equal 1. 10xy divided by 5x, so we can divide the coefficients and then subtract the exponents, so the x's cancel and we're left with y. Now how could you possibly check to make sure that you factored this correctly? Use distribution to see if you get back to your original problem. So if this is truly my GCF and I distribute it back in, okay, and multiply, I should get back to my original problem. Okay, so this is my final answer. I have factored that expression using GCF. And that's what we want it to look like. Okay, so we're going to make it a little bit more difficult now. I notice that my first term is a negative, okay? And whenever we're factoring, we never want to leave the first term we never want to lead with a negative. So when I take out my GCF, I want to take that negative with it, so that the first term inside my parentheses ends up being a positive number. Okay, so I just want to keep that in mind. All right, so the GCF here, I've already decided I'm going to make it a negative. All right, between 4, 2, and 6, you could take out a 2. X squared, that should be z to the third. And I could take out a z. Put a little crossbar in my z so that it doesn't look like a 2. All right, so if my GCF, okay, that's going to stay on the outside. So I'm going to divide each term So I'm going to use exponent rules now to divide each term by the GCF. Okay, so I end up with just a 2 because my variables cancel here, plus 1xz. Remember, I subtract, minus 3x squared z squared. Okay, and again, distribute your GCF back into the problem as a check to make sure that we factored this out correctly. All right, this bottom example, all right, I'm looking between 3, 6, and 9. I could take a 3 from each one, and x squared x and a constant, I can't take any variable out. So the only thing I can take is that constant. Okay, so we're just going to divide that out and make our final answer look like a distributive problem. Now, sometimes, okay, we are factoring a problem and it doesn't look like there is a GCF. 5x and 17y, they have nothing in common that I can take. But if we remember, what is always a factor of every single number? You could always take out a 1. So if my GCF here is 1, I divide that out from each term. Okay, and I understand that it hasn't changed any values in the problem, but now it looks like a distributive property. And we do want to get in the habit of putting a 1 for a GCF, okay, and factoring that out. That is going to affect us in the future. Okay, our final two types of problems here. Okay, we want to identify what is actually happening. So 2 times a plus b and 3 times a plus b. These are two separate terms. Okay, so even though there's an a plus b inside the parentheses, one is being multiplied by the 2 and one is being multiplied by the 3. So remember, multiplication makes a term. So if I look at each of these individually, okay, what factor do they have in common? They each have an a plus b. I could take that out. I could take the whole parenthesis out as a GCF. That's allowed. So it cancels from here, and it leaves me with a 2. And it cancels over here, leaves me with a 3. So I understand that you could do 2 plus 3. For the purposes of our factoring and what we're trying to accomplish here, we're just going to leave that as two separate terms for right now. So doing this again in our last example, okay, remember x times y plus 2 and z times y plus 2. These are two separate terms. And they each have in common this parenthesis value, y plus 2. So a parenthesis could be a GCF. I could take that out from each one, divide it away, and we're left with x minus z inside the parenthesis. All right, so GCF is a pretty simple concept once we, do a lot of practice with it. It is probably the biggest part of our factoring chapter. So we really want to make sure that we have GCF down before we go into our other methods for factoring, because they are all based on GCF and then each subsequent method. Okay, we're going to build on it. So that is everything for 7.1. Please write down any questions that you have so that we can talk about them during our next class, and I will see you guys at that time. Thank you for watching.